And she goes, okay, Mama. And she just laughs at me. I don't care.
That's all right. That's all right.
I
That's
I
right.
like I like doing the abacus.
Yeah. How
Yeah.
did you do on the book, Tammy?
Well, I'm still doing two pages at a time,
Okay. Okay.
and I'm actually, because you have the two-step uh problems in here and everything.
Oh, okay.
Yes.
I do
Thank you. Sorry.
oh, there we go. I do have to take my time.
Oh, yes. Good.
It has slowed me down,
Good.
and that's all right. I'm okay with that. But I
Good.
would do it. I would do it, and I'm like, "There's not enough beads," and I'm like, "But there should be enough beads," and I'm like, "Wait a minute, two step." I'm, I'm like, "Fine,"
Yes.
but it slowed me down.
Good. Good. It should,
Yes,
because now you're getting to the point where it's meeting at your level.
yeah. Well, and I'm still trying to make sure I'm not looking at the problems, because if I look at the problems, I know the answers. So
True.
so I put in the numbers I got to put in, and then I work it.
Yes.
So, and I'm writing the problems down. Well, I'm not writing these down, but I'm going through and I'm working one row of numbers at a time. Not rows, but you know what I mean.
Columns.
Yes. And I'm still preferring to go from the left to the right, though I do try the right to the left and I just get aggravated. So I go from the left to the right because it's easier for me. And
Yeah.
that's really weird.
If it's easier, then go with it. Because the idea was to experiment to see what's better. And I like to go from left to right. But
Yes.
if you wanted to bring some challenge, then you go right to left.
And the big thing is if I find that I'm having trouble doing the left to the right, then I will go from the right to the left, and then I will make myself redo it
Yes.
a couple times, going both directions,
Mm-hmm. Mm-hmm.
just to get that in my brain, ingrain it
Mm-hmm.
in my brain as I'm doing it.
Mm-hmm.
But it doesn't mean I'm not going to have problems going down the road. It just means I make myself do it multiple times.
That's fine.
So
That's good. That's good because it's all about practice and we're all
yes,
still learning. So
yep. I think, let's see, in this book I've made it to puzzle A on page 53.
oh good.
That's where I did the first problem, and I said, okay, I'd already done 2 pages. And I was like, no, no, no. So I've taken my time
We all good. Good.
because this I don't feel I can rush through it. There's just no rushing.
Yeah, yeah, yeah.
So
One of the Chris has already finished the book and she's waiting for multiplication.
oh, bless Chris.
Chris is I don't know how to explain her. She's one of the regulars, but I think she's usually on later at night because she doesn't sleep.
Yes.
She doesn't sleep, so she'll be on like at 3 in the morning. So that's like 12 o'clock for me.
Ooh, ooh,
Yeah, she's one of the later ones. So I have my early ones and I have my later ones.
yes.
And then I have
And
my deep thinking ones, you guys.
yes, most definitely. But
Alyssa,
go ahead.
I was going to ask Alyssa. So, did you want to redo the division problem?
Yes.
Okay.
But can I share a couple of things?
Yes.
Okay, so first of all, when I sent you that email, I was totally embarrassed because I just did not see the patterns. And
Yes.
then I went and I worked the problem with my niece
Okay.
and I showed her the patterns of the first dividend and the second dividend.
Yes.
And she wanted to keep my paper.
Okay.
She liked the process, because sometimes when you're doing with the mainstream math, you don't really see that those are dividends.
Yes.
But I worked the problem a couple of times.
Yes.
But also, I really liked how you talked about how you have the student teach the teacher.
Yes.
So I've been having Abram do that.
Nice.
He doesn't want to teach me, no, because I get too involved with him.
Yes.
But he would actually go, so he would say, are there enough beads? No. So you bring down the 5 and you plus the 2 or whatever.
Yes.
However, when he was working with the problems, for example, if you have, let's say, +3 equals plus the 5 minus 2, he would say, actually, no, he did it with plus the 2 is plus the 5 minus 3. He
Yes.
would say plus the 2 is plus the 5 minus 2.
Oh, yes. Yes.
So I thought, there is always room for error, and there's always room for making a mistake. So what we did is we actually did the problem just exactly like that, to see if he could recognize where he went wrong.
Yes.
I think it was with a 4 plus 2.
4
No,
4
let's
plus
see.
2.
I
Okay.
think it was.
Okay.
And then he caught himself.
Nice.
So what I did in the book is I went and I underlined, remember the friends of 4 is 1. I did it in all of those sections. I would just highlight, remember the friend of 3 is 2. And I
Yes.
highlighted it in like green or something like that, so that
Yes.
he would be able to see it. So we've gone through everything with, add plus the 1.
Yes.
And now we're on the color by number.
Good. Color by number.
So we're on the color by number for the first one.
Okay, so let me, oops. There we go. So what you're looking at is the color by number. Oh, the first with the owl.
With the owl.
Yeah. Okay, good.
Yeah.
So yeah, how are you going to do it? You're going to have him answer it on the paper, and then you're going to color it in?
I'm going to have him choose the colors that he wants, color those first.
Yep.
And then we will just work each problem.
Yep. Yeah. Yeah. I would recommend putting the answer here. If you
Okay.
want to, you could have him write the formula here. If you want to continue to have him write the formula.
I can do that. And he took all those cards and he just threw them and he said, okay, you gotta go find it. He did that to me.
Oh my goodness.
But when we play the matching game, he knows that +3, he knows that he needs to have the plus the 5 minus the 2.
Yes.
So he knows that.
Yes.
Then he just, and he talks about going to the cat tree, because I think after a while we'll go to your foundations page, where it talks about you don't have enough beads. So then you do the +5 and you pick which formula that it applies to.
Right.
So that's kind of where we're at. And now I see why you say, well, maybe we give them too much information. Maybe we just let them practice. When he is doing the simple problems, I say, well, Abram, so how come you don't have to use the formula? I asked him that question.
Yeah.
And so I hinted at because you have enough beads. So the
Right.
second time when I asked them that, um, how come you don't have to use the formula? And he goes, because I have enough beads to add.
Yes. Good. Yeah. And that's the part of the critical thinking that happens, right? And that's something that we don't teach the kids when they're young in mainstream.
Because you're
Right?
just teaching how to do something, but you're not seeing the why of it.
Yeah, but then it goes back to like, even if I didn't have the abacus, the problem with mainstream is if I have so many numbers, I can just keep adding until I have no more. And so you're still doing a 1-to-1.
Mm,
Does that make sense? So if I
I think
had
so.
1, 2, 3, 4, 5, I have 5, I'm going to add whatever. I'm going to add another 5. I just keep adding. So I'm counting again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what in mainstream, I feel like what they're doing is they're continuing to just keep adding, but not but there is no extra concept to be like, well, what's the restriction? There's no restriction. It just depends on how many pens you have.
Is it when they're showing something visual? Is that what you mean?
No, it's the difference between that there's restrictions on the abacus as opposed to numbers on just as opposed to like pens. Because
Oh,
the
okay.
abacus has a restriction, you can actually be like, oh, okay, wait a minute, I don't have enough beads, right? What can I do? It's like the difference between a blank piece of paper and a restriction on the abacus. A blank piece of paper can be anything in the world, but the abacus is there's a confinement and there's a constraint. So now we have to do is we have to think, okay, well, I have my constraint. How do I work it? As opposed to like in life, right? We have our constraints. We can't walk as fast. Well, what do? Well, we could take the bus, we could take the car, we could take, you know what I mean? So we work with our constraints. Abacus mimics that. We have to work with our constraints. It cannot be sky's the limit until you get to like higher math, like when you do research math, right? Then it doesn't matter. Everything gets thrown out the window. But when we talk about the fundamentals, right, we should have a restriction, we should have a constraint so we can work with it, just like we give boundaries to our children when we guide them. Well, you know, you walk on the sidewalk, don't walk in the street. That's a constraint. Put some clothes on, you know what I mean? That's a constraint. Or you can walk around naked. No, there's constraints that we live in. And I feel funny. It's just interesting that in math, they don't give you a constraint. They're like, just sky's the limit. It doesn't matter. But there's constraints.
Yes,
There
that makes
has to,
sense.
I think there has to be.
Right? If you can
Boundaries.
just, yeah, boundaries. If you can just make it so it's a little bit more manageable, then it's easier to automate that. It's easier to make it it's so much that you can automate your
Automate.
thinking. Yeah, automaticity.
So
It's like,
the boundary for the abacus would be that you only can go up to 9.
well, that's the boundary. No, see, but that's the boundary of just regular math. You can only go to 9 in any specific column. So if I have my number, right? Let's say we have 348. 348. If you break it up in individual numbers like this, you can only go to 9. You can only go to 9.
Right.
900. What's after 900? Well, 90. After 90 is, so the abacus just visualizes your constraints,
Okay. Yeah, that makes sense.
right? Because what's after 999? Well, what's 1000? Well, that's not the same number. What do? We reset. That's a 0. We reset to go to the next number. So then it goes back 1, 2, 3, 4, and it just goes over again.
Okay. Yeah.
So yeah, and it's funny, right? Because the abacus shows us the constraint, but in mainstream math, they feel like the sky's the limit. But no, no, no. Let's see what it is. Let's break it down to what it is.
Oh, and that's when you're saying breaking it down to its smallest components.
Yeah.
What I was wondering if we can do that, you know, a division problem, it doesn't necessarily have to be that one, it could be a 2-digit one. But I was wondering if you can show the difference of where, because they're doing estimations in division, And I
Oh,
don't
yeah.
quite understand why they're doing that in comparison to how you're doing it.
They, they do estimations so they can make the numbers easier to digest. That's why.
But aren't you doing that by doing
Breaking it up. Yes.
one digit at a time?
Yes.
So what's the difference then?
What's the difference?
Yeah, if they're doing it by estimation, one of the things my niece told me, she goes, but it's so much longer on the abacus when you're doing the one digit at a time. I said, but yeah, but you can see the pattern of the the dividends on top. I don't know how to verbalize it because I don't know how to explain the difference.
Right.
But doing this problem again, and then doing how they do it in mainstream and why they're estimating, and why is it better to do that with the abacus, or what are they trying to show when they're doing a mainstream that way? So I'm just curious.
Well,
But I do.
in the mainstream, you would be using the 52 at first instead of doing 5 and then 2.
So
On the
main,
abacus, you're
yeah.
how do I put this? Basically, we're doing one number at a time, but whatever you do to one number, you have to do the other, where the 52 is the
Mhm,
divisor.
mhm,
Yes.
And then in mainstream math, okay, you got the number 52. Well, that there's going to be nothing that's going to give you 33, so you have to go to 332.
mhm,
And so you've got to divide the 332 by the 52. Whereas on the abacus, you're doing 33 divided by 5. You're bringing the 2 down, then you go into the 12 divided by the 2. You're doing one step at a time,
mhm.
one number at a time. And Main
Mhm.
Street says, well, we're going to do it the whole way.
Yeah, I think they do that with the problem, but I don't. They're doing this estimation thing, and
Es-
is that
Oh,
estimate.
different? Yeah.
It is. I think it's a little different. And I don't know when they would introduce that. Do you have a question that I can look at in order to see, or when they do it? Is it right now? Is Abram doing that right now, or is that later in
No,
the?
I think that's a little bit later. I mean, he's not even into division right now. But
Okay.
it's just that I remember you did a problem online where you talked about how they did estimations with a division problem.
Oh, I know what you're talking about. I know. You know. I know. I know what you're talking about. Let me see if I can find that book because I was trying to research. So okay, let me see. Let me see if I can find it.
Okay.
We're gonna have to. We'll have to. I'm gonna have to freestyle it. Okay. So is it this one? No, it's not this one. Okay.
No. But you could take that same problem and show how they do the
How they do it.
estimation
Right.
and versus how you do it with the abacus, and what are
So
the discrepancies.
the the discrepancy of doing the discrepancy of doing it the estimation way is because it's not long division. It doesn't translate into algebra doing it that way. So from what
Oh.
I hear of, and I hear other people talk about, I don't know algebra, so I don't, I don't know what the I don't know the difference. But as they mentioned, they want to, yeah. So what is there was a yeah. So so let's say this question was 52 divided by 320. So the estimation is, well, I know if I do five, they broke it out. I know if I did 50 times 2 is equal to 100. So that means I know that I could do 2 here. So what they do is they do repetitive minus. repetitive subtraction. So we have to minus 100, right? So then it gives us, no, that's not right, because it's 52. So it's 154. So 104, right? So then what they do is they take away. But you're still left, what is it? 2, 3, nope, 1, 8. Is that right?
Yes.
Yeah. I'm just excited to be able to, and I can't think straight. So then the next one is like, okay, well, we'll do it again. 52 times that by 2 is equal to 104. And then all they do is repetitive just to make it done. So it is a little bit, obviously it's a little bit longer this way. So this is 4, 1, 1, and you do it again. Oh, did I do it wrong?
Well, you
I
did
did.
correct, right? Yeah.
Yeah.
There you go.
I see. Yeah. So then you would just keep going until you get to 0. I forgot the strategy, but we're gonna keep going. So it's 104. So we do 104, which is what, 108?
8.
That's not right. I missed something here.
You
This
had to
should have
bring
been,
down to 8.
yeah, but I did
So when
something
you
here.
did the 332 minus the 104,
Yeah, up here.
then is that right? Because that would be a 2. So it would be
Right.
2 to 8, right?
Is it 2? Oh yeah, right. Sorry, I can't even do it. Yeah, 2, 2. Yeah, 2, 2, 8. And then yes, so this would be a 2, and then yeah. But okay, let me redo that. I'm just too excited because the reason why is what I
don't even see the dividend in that. So you're
well,
saying it's not long division because it doesn't show what?
it doesn't show the process of, it doesn't do long division. What you're doing is you're doing repetitive subtraction. So 3, 3, 2, 8. Okay, let me calm down because I'm too excited for this. So we did this. Okay, you know what? If I did, see, I don't do it this way because I gotta think. Okay, so if I did 4, we know 4 times 5 is 20, right? And then 0, 8. We could do that, right?
Yeah.
So we put we leave, I think we leave it there. 2, 0, 8, right? So this is 4, this is 2, this is 2. No, this is
1.
no, this is 1. Sorry. So we have 2, 1, 2, 4. Gosh, I can't do it. Okay.
That don't seem right.
It doesn't seem, what, we're going to keep going. So then we do 50. What I think it's, 50 times up by 2 is 104. So we do 104. Then we do 208. I don't even know how they get the quotient. I forgot. I would have to review the thing. So we did again. 52 minus times up by 4 is 208. So what do? I think they add everything. That's not right. That's not
They
even
add
right.
they add the first 2.
Oh yeah, there you go.
So
They add
that
the
gives
first
you
2.
6.
That's
and
a
because you
6.
brought the 8 down.
Right. And then because we bring down the 8, then you have the 4. Is that right?
Yes.
Oh, okay.
Huh?
Yeah, I don't. So yeah.
So you're
Because
adding those two to make the first dividend?
yeah, to make the first quotient.
Yeah, quotient, sorry, yeah. Sorry, quotient, yeah.
I don't even know how to spell quotient. Quotient.
Okay.
Whoa, there we go.
Yeah, that's what I meant. Yeah.
Yeah. So this is the dividend.
And that's the divisor. Those are the
And then,
divisors. Yep.
yeah, divisor. Yeah.
Yeah.
So because I have more, I still have enough, then you add these two. I don't do it this way, but yeah. So it's a little bit longer. It's a little bit longer this way. This is the estimation that you're talking about, because they're trying to find what they're doing. But what they do is they take this whole thing and they try to find it. And then that means what? That they have to work out how to do multiplication here.
Well, and honestly, if they did it like 52 times 1, then 52 times 2, 52 times
Yes.
3, you
Yes.
would end up with 6.
Yes.
And so 6 would be your first quotient.
Yes. So 104. So in one of the mainstream math, I was trying to figure out how they did it, and they take the numbers as a whole like this.
Yeah, like Tammy
Yeah.
was saying.
Yeah,
Uh-huh.
exactly. And so you would have to, and that is what exactly what how they teach the kids.
So it's a process of elimination.
One, it's a process of elimination, but two, they're not solidifying the concept of the multiplication facts.
Oh, because it's so big.
It's so big. We don't have a multiplication fact that does 52 times 3. So then that's why they're like, you got to do mental math. You got to do mental math. You got to know this automatic. I'm like, I don't know. So it'd be what? 2, no, 1, 5,
5,
6.
6.
Yeah. See, it takes me time because it's such a big number, right? We know this one because it's 204, and then we do it again. So this is what they were doing. I mean, yeah, this is what they were doing in one of the videos that I was researching. How do you do a 2-digit division question? There's not a lot of videos on 2-digit division questions. I realize this.
Mhm.
So it's 25, 26. So what I'm doing in my head is I'm doing distributive property. If I do this, right, I know 6 times is 30,
30.
right? I know 6 times 2 is 12. So
Yeah.
then I add it together, 3, 1,
3,
2,
Mm-hmm.
right? But I'm doing this in my head. That's why it's taking me a little bit. But if I get obviously if I get too excited, then I kind of mess up. And then I don't know, you could keep going. But you don't have to. But if you need to see, and that's the thing in mainstream math, like you should go one more just to see what's going on, because
Why?
you need to go above to know that you can't go anymore.
You're oh, okay, but I mean,
So 35, so it's 360, 64.
you already know that it's going to be larger because you're multiplying by 52. It's gonna,
You know, but when they're teaching the kids don't know. So they tell them to go one more over to get to this point.
so why don't they tell them why?
I
Instead of, I can see where when we were, it was so cool when you took the you did the distributive property
yes.
to get that number, or no, you did a division. You did 52 into 208. That's what you did, and then you were able to get one of the, part of the quote, and that's double checking that you did the work right. So, yeah, okay. So there's no long division.
Yeah.
You're
They're getting to a point where they don't want to do long division this way.
huh,
That was the estimation. They just say, pick a
that's
number, pick whatever number, and then just do it. It's like, okay. I mean, there's many ways to do math.
yes.
But I think the fundamentals, there should be a little bit less guessing. I feel like there should be less guessing in the fundamentals of math, because when we get to the higher math, like calculus, that's when you start guessing,
Mhm.
And when I was in school, because I'm 55, going to be 56 next month, we had to know our multiplications. So we had to know that 33 divided by 5, the highest you could go was 6, because
Mhm.
7 was 35.
Right, right,
That's
right,
so much easier because you already know. Oh, yeah. Okay.
right.
Yeah.
Like, yeah,
Mhm.
but see,
All of
that's the
this?
thing.
Oh,
Yeah. But see, that's what you do is you do critical thinking. You show the kids how to critically think the numbers, but this doesn't show them how to critically think. They just say, work it out. That, I think that's one of the difference, right? We're bypassing giving them the concept of, how am I looking at this number and how do I answer it? They're just,
Not
no,
until
just,
late.
yeah, just find something and then just go with it. It's like, Oh, okay. But yeah, yes.
I did do a crash course. I'm like, you know what? Let me look at what the divisor, what the dividend, and what the quotant's role is
Yeah.
in division itself, and which really helped a lot better. But then it then once I did that, then I could see why you were doing the individual divisors. It's more manageable because we know that 5 times like what Tammy said, that 5 times 6 is 30. It's
35.
just so
Yeah.
much. Yeah.
Yeah.
Yeah, it's easier.
Mm-hmm.
So yeah, now that I see this, let's do it the Abacus way.
So did
No,
I use this one? So when we're looking again, we have to look at our how many numbers. We can see what we're doing, right? Oh, I'm sorry. That's the wrong way. Okay, there we go. So we could see the numbers we have. We have our question. We want to critically think what we're doing with it. We need to understand where to put our quotient. We're going to do 4 because there's 4 dividends. We minus the divisor. There's 2 divisors. So we take away 2 digits, 4 digits, take away 2, it gives me 2 digits. That means I'm going to be in the 2-digit column. 1, 2. That's what we're doing. Does that make sense? We're just finding our placeholder. That's what we're doing.
mm-hmm.
This is my placeholder. Now, because I know I'm going to start here with my quotient, something like this. Is that right?
It's
Can I
actually
do
over
that?
one. It's over one more.
Is it over here?
Yes.
Okay. Oh, yeah, you're right. Okay. So I'm going to start here.
Okay.
I'm going to put my dividend on my abacus.
Is that supposed to be over one more?
No, we're good.
No?
Yeah, we're good.
it just looks
Okay.
weird. Okay.
Because I thought you had it over one more.
No, because 5 cannot go into 3. This happens only if it's possible to go into it. Let's keep going. Let's keep going. So what are we going to do? We're going to do 5 times what is equal to 3. Can't do it.
Nothing.
We got to
Can't do it.
No.
bring it down, right? So we got to do the 3. What times 5 times 6 is equal to
30.
30. So I put 6 here. Take away 30, take away 3, take away 0. I'm over here. Then, because we did 6, 2 times 6 is equal to
12.
12. Take away 1, take away 2.
Mm-hmm.
Do you see how I line it up as well?
Mm-hmm.
Because if you notice, if you think about it, this is actually 50 times 60. So we're doing this.
Yes.
And then this is just 2 times 2 is equal to 12. So our final answer is 312.
Mm-hmm.
312 take away 332. That's what we were doing,
Okay.
right? So now what's our next number? Well, we can do it again. I got to change color. So I don't know, it's red, that's red. So we have our next number. We look at here. No, where are we? We're looking here. Wait, did I do that wrong?
No, you should be.
Oh, I didn't take it away. So we have take away. I am having a brain fart. Oh, what? Take away 12, take away 1. Oh, sorry. So this is supposed to be the 2, right? Oh, so it's, sorry, 300. Bring down the 2. So it's 3, 2, take away 12. There we go. right? So this is what we have. I'm sorry, I'm messing this up. So this is a 2 here. So we start over. Let me start over. Our next number is this, 2. That's what we're looking at. Does that make sense? Now
Yes.
I don't need to work with this anymore. I just work with this. I have 2 that's left over. So the question is 5 times what is equal to 2? That doesn't work. What do? I have to bring down my, I have to make it a 2-digit number. This is my 2-digit, so I make it 20. So then we know 5 times 4 is equal to 20. That becomes 0. Whatever you do to the first quotient, you got to do it to the second quotient. So I add my 20. There's 4 times 5 is 20. 2 and then 0, right? I'm here. 2 times 4 is equal to 8. 8 is a single digit, so I have to make it a 0, 8. So it's a 0 and take away the 8. Okay, got it. Ooh. So my final quotient is 4.
Well, the total is 64.
Oh, yes, thank you. So my total is 64. Yeah. I got to reword this. I haven't worked on my multiplication. I haven't worked on my division, the division book yet to make it better to talk about this. I almost have the multiplication one outlined.
Oh, cool.
Um,
So I have a question. So why
yes,
did I think that when we were putting the space for to put the quotient, and then you put the dividends right next to it, why did I think you had to go over one? Why
this
did I
way
feel like it
or this
the
way to
whole
the,
the 3328, it's right
yes,
next to the the the
yes,
numbers for 64.
3, 3, 2, 8. That's what I would do. Yes.
Yeah. So why did I think you had to shift over one? Why am I
Where,
thinking that?
where am I
Because
shifting
that's what
to?
I do.
What are you shifting? Are you shifting to the left more?
I'm shifting more to the right. I'm taking
Oh,
the
so
dividends over. Yeah.
it'd be like this, 3,
Yeah.
3, 2, 8.
Yeah.
I do that,
Because
and I mentioned it because I need a divider.
no, it's because you're in Abacus, in the way I'm teaching Abacus, we're using the dividend to help us give us a placeholder. So our dividend, our quotient will always be next to our dividend.
Oh.
So you're separating it as 2 separate things, but it's
Yes.
not. I'm using it as a helper. So as I move across, my quotient will move with it.
Ah, I see. And that's because you're subtracting. Because
Yes,
really, because you're kind of like redividing into a smaller dividend.
yes,
Okay.
yes,
And that's what the pattern I noticed on the paper.
yes,
Oh, so okay. Okay. Yes, because it shrinks. It goes
yes.
away.
Mm-hmm. It goes away as we go through. So then as it goes away, it will take, the quotient will take over its place.
Oh.
Because remember we had what, 208, right?
Yes.
Yeah.
See, we have no more, we have room right here to put in our second number. So we add the 4. The 4 goes here. We're right next to our dividends. I don't know how the other Abacus teachers do it, but that's how I do.
Then yeah, you're in. So you're your second quotient, and then you're taking that, and you're how many can go into 208?
Yes,
Oh my goodness. Oh, okay. That's the first time. Okay, I saw it visibly on paper, but
yes,
I didn't notice that on the abacus. This is the
yes,
first time I've noticed that.
yeah. And so, yeah.
how do you verbalize that? I'm always asking you.
Well, how do I verbalize what? That it's a moving dividend?
Yeah, no, I'm getting it. I see it. I see the 4, and then it's a 208. Okay, I'm
Yeah.
getting it. I liked how you explained that. Okay.
The difference is I explain as each step. And I think one of the things that Abacus does not do is that they assume that you could see it, but they're not understanding the actual explanation. And that's why when you look at my books compared to the other books, I do a lot of visual and I do a lot of labeling and representation.
Yep.
That
And
does help.
yeah, because there's a I was listening to this one video, and there was a difference between perception and something. It was another P word. I forgot the name now. But perspective and perception, your perception will always be very subjective. But what I try to do is I try to change my perspective to how you would see. That's why it's good for me to know what you see. So that's what makes me a different teacher is I try to see it in your perspective.
I see.
That's why I can explain, because I know my abacus so well, I can explain how you see it and how it makes it into abacus.
Yeah. Like I said, this is the first time that I noticed that 4 and how it just
shows up. Yeah.
Yeah, it just shows up.
And I'm like, how does it show up? But that's the difference. So I think in just in general in teaching, the way sometimes the videos come across, there's not trying to understand how does somebody else see it.
Well, I think sometimes when we're, when you're teaching math, you just teach it and you just expect them to get it. But if you're not able to see where they are struggling, they're not gonna see the steps either.
Correct. And as simple as understanding that this is not 2. You know how some people think, well, that's 2. It's like, I understand how you got this is 2. This is not 2. This is 6. Because we have the top bead and we have the bottom bead. It's a very easy thing, but understanding the perspective of how somebody else does it, it's easier to be like, oh, and then you can explain more. When I add the 5, I take away the 5. And it changes my way of teaching because now I know where you guys are coming from. So that's where we come to here.
Yeah, it seems so much easier than the other way. I mean, you are doing subtracting, but yeah, this is more understandable.
Yeah, it's the manageable chunk. So like, I don't teach it this. That's why I got kind of mixed up here because I'm trying to get a better handle of how to teach it better. But if you really think about it, what we just did is we did 56 times that by 6 is equal to 312. So all we did is we take away 3, 3, 2. So then we have 2, 0, and then we bring down the 8.
No.
Yeah.
You wrote 56 times 6.
Oh,
52.
Yeah, 52.
I'm looking at that. I'm like, no.
but like, so in abacus, when we break it up, and we're not used to breaking it apart like this, obviously, right? We're always used to having it grouped like this.
Yes.
So, and it's the same thing with multiplication, right? We do 24 times that by 7, let's say, right? What do they do? I don't know what they do. They
do it one at a time because that's all you.
Oh,
that's the only way you can.
That's the only way you can. That's right. And so that's the funny thing. So this way, yes, that's right. So is it 8, 2? So it's 14. So there's a 2 here.
168.
Thank you. So we do, in mainstream, you break it up. You do the kind of the distributive property, right? You take one here and then you take the other one here,
Yes.
right? They break it up into 20 times that by 7 is equal to 140. And then 4 times 7 is equal to 28. And then you have to add the two.
Okay.
However, what do we do? In division, they don't do that. It's another strategy. You just need to know how to break this up.
Yeah.
You know what I mean? So you need to know, 24 times 5 is, oh my gosh, is 1, 1, 2, no, yeah, right, 1, 2, 4.
No.
That's not right. Is it? No, 0.
5 times 4 is
It's
20.
20. And then, yeah, there you go.
And then 120, yeah.
Yeah.
Yeah, that's fun.
So then and then you need to know that 6 is 1, 4, 4.
4.
Right? So instead of breaking it up as we do in multiplication, they expect you to know the whole multiplication fact. But this is not a fact
Yeah.
family. So yeah,
No.
and that's what I'm saying. It goes back to it's one strategy and then it's another strategy. Whereas in Abacus, it's one strategy and it's just the reverse. We break it up in multiplication, we break it up in division. If you know how to add, you know how to subtract. If you know how to multiply, you know how to divide.
How to divide.
Let's do one more division.
Okay, let me find a nice one.
Because that's what stops me is the division. So I'm anytime you want to do division and anytime you want to do it multiple times, I will be right there and I will write it down every time. So I am good to go.
Are we going to do still the 2-digit one?
Sure, let's try one more.
It's a lot harder to find numbers. That's why. That's why I
is
asked.
it? Then okay,
Yeah.
if it's too hard, then let's just go to the I think what would be cool is if we could actually no, I don't even know if I can do it. I no, I can't
Okay,
teach it.
I got
can't
it.
teach it.
I got it.
Where we could teach like a small portion of it, but I don't know. I don't know if I'm ready for that.
Well, you can. It's just I would just be guiding you, and that's what I do. Is I just guide you what numbers we're doing. So let me do. Okay, let's do 61.
You gotta bring it down.
Yep. Oh, hold on. 3, 2, 9, 4. Yeah. Yeah, I just needed to copy that in that question. Okay, so there's the question, right? What is the first thing we do?
Put the dividend down in it. No, the first thing you do is see how many places.
Yep.
Yes, right? How many places do we have?
You have
2.
Yes. 4
Yes,
take away
4.
2 is equal to 2.
2.
So I'm going to go here. I'm going to go here because I know what my answer is. I like it because I like the colorful abacus as opposed to the single color when I do explanations. I try really hard to stay with the colored one because it's a lot easier to see when I move the numbers. That's why. So because I have my quotient here, I'm going to put my dividend. 3,294. This is not, we're not paying attention to the place values. We're just using it as a placeholder. We're going to use our dividend to subtract. That is why I put here.
Okay, there we go. Okay.
Right. So it's a placeholder, not understanding that this is the ones, the tens, the thousands, the hundreds, or whatever, thousands. Right. We're not doing that. What we're doing, it's a placeholder. So the first thing we're going to do is we're going to say what? 6 times what is equal to 3?
3.
Why? Because we need to do 1 digit by 1 digit. We need to compare. We can't do it. There's no multiplication table that does 3. That's why we got to make it a 2-digit number. 3, 2. Let me get a 2. So what would be what am I doing here?
So
So,
6, go ahead.
so then we get the quotient. The quotient as of this moment is a 5
Yep.
because it's
6.
6 times 5 equals 30.
Yep. But remember, when we do 30, right, it's actually
Yes.
300 because it's a 60 times 5. Is that too much information? I believe it's too much information. That's why I don't talk about it. But in
Well, see,
argument,
in my brain, I'm doing the 6 and it's dividing the 32.
yes,
So I know that part is 2.
yeah. So I add the 6, I take away the 3, and I have the 2. Then we do it, right? 6 times 5. No,
1 times
1
5.
times 5 is equal to
5.
5. 5 is a single digit, so it's a 0, 5.
Okay.
What do we do? Well, this becomes down. This becomes 2. Sorry. This becomes 2, like this, right? We bring down the 9. We take away.
So it's 4. So
Yeah. So we
so
take
the answer is 24.
the answer is 24. But see, I don't have to do this on the paper. I can just see it. Take away 4, 5. It gets confusing because I have to do it on a paper. So my answer here is 2, 4, 24. Let me bring it down. So so now we have to redo it again,
Right.
right?
And this is the part where I like, because last week you took the 244 and you divided the 60 by the 61. You separated the problems, and that was like,
Yes.
oh, I can do that. But
Yeah. Yeah. Because what we have to do is we have to reassess again. So it's essentially this is a new problem because it's a new quotient,
true.
right? So when we're looking, it's what? 6 times what is equal to 2? Can't do 2,
No.
right? We got to make it a 2-digit number, which is this. So that's why it's 24. 6 times 4
Yeah, 6 times 4.
is, add the 4 here, take away 20, take away 4.
6 times 4 is 24.
Yep.
Oh, never mind.
You're right. And then what? 1 times 4 is equal to 4. 4 is a single digit. We have to remember it does 0, 4. So we do 0 and then 4. So because we bring this down, we just take away the 4. And it works itself out.
See what you meant by you knew the answer.
Yeah. Yeah.
Now, as you get into doing this more, you won't be writing down as many of these steps, but you will still be writing down some.
Yeah, exactly. Exactly. Like I
It's
get confused even writing it out.
it's easier to keep it in line
It's
Is it
easier.
after you do
54?
it.
Is it 54?
Yeah.
Is it 54? Yeah, you're right. It is 54. I moved my abacus. You're right. 54. But yeah, going back, putting it on paper is obviously different than putting it on this. Right. So that's why when I do it on my abacus. Exactly what
Okay.
Tammy does, right? I keep everything on my abacus.
Yeah,
I don't write it
that's
out
what I
like this.
do.
But
I'm writing it out right now only because you're explaining it, and I'm still getting familiar with it.
yeah, processing it. Yeah. Yeah. I write it out. I write it out so I can tell you what I'm thinking. Because I could tell you all I want, right? But it's different when you see it and it's different when you hear it.
Yeah. And it's totally different when you see it on paper.
Yes, exactly. Exactly. And so yeah, like if I really broke it out, what would we be doing? This would be really 60, right? Times 5 is actually 350. Sorry, 300. And then we do 5 times, and then what we do is we know that this is 0, so it'd be 300. So what did we do? We did 305. We minus 305 because we know 305 61, because we know 61 is equal to, times that by 5 is equal to 305. See, doing it this way does this for me by itself, right? I don't have to go through the whole line of 61 times 4, 61 times 3, 61 times 2. I don't need to do that because I can break it out.
Yeah.
So then what's the next one? Then we know, yeah, 61 times 1 is equal to 61. No, 4. We did 4. Sorry. 61 times 4 is equal to what? 244. It's less steps in mainstream, but it's a little bit more brain intensive.
Yes, that I will give you.
Yeah, it is more brain intensive to do it this way.
So then basically you can take 61 and divide it into 300. You can take 61 and divide it into 244 and get your quotes.
Yeah, but it's not. It's actually 61 divided by 329, and then it's 61 divided by 244.
244.
Yeah.
Oh yeah, 329 right there.
Yeah. Yeah.
Okay. That's
Yeah.
what that is.
Mm-hmm.
Huh.
But it's actually 3,290.
Oh.
That's why you get 50. That's why you get 50 here.
Okay.
And this is why you get 4 over here.
I see.
Mm-hmm.
Huh.
Yeah. Yeah. Don't forget the 0, because that helps our paycheck. Right? More zeros in our paycheck would be nice.
Oh, yes, it would.
So basically in dividing, because we're taking the dividend and we're shrinking it, but at the very beginning on your abacus, it's just a placeholder.
Yes.
But when you're doing the problem, you got to remember that it's actually that big of a problem. It is actually, when you're subtracting 32, it's really 3,094 is what's left. Right?
I'm sorry. I didn't understand that. Say that again.
Remember when you have on the side, you kept on saying you got to remember that, it's 60 times.
Oh, right. 60 times 5. Yep.
Right. So really, when you're putting 300, that's really 3,000, right?
No. This is 300 because it's 60 times. It's still 60 times 5. What we do in abacus is 6 times 5. Right. In abacus, we're doing 6 times 5 is equal to 30.
Okay.
That's what we're doing in abacus. But in mainstream, they want to make sure you know that you're working with the hundreds.
Okay. But on the abacus, we're not really worried. We don't worry about that, is what you're saying.
Yeah, we don't worry about it because our placeholder
grows.
Our placeholder, our abacus holds the value of the place. There's just a
Okay.
few things that we need to know. There's a few things that we need to keep in mind.
Okay. Okay. All right.
And that's
Yeah,
it.
that's
Yeah.
it. Okay. All right.
Um, yeah. And so for what it is, I mean, and that's the difference between abacus math and mainstream math is we break it down into manageable chunks. That's what I would tell your niece. It's breaking down to manageable chunks because when you get to bigger ones, you would have to do 61 times 4 or 61 times 5 or 61 times whatever. Whereas in abacus, we don't need to. We just need to know our multiplication fact and we just need to know how to work it.
Mhm. Well,
Okay.
even though we did this problem, I thought I had it, and so it's a lot harder to do 2 digit.
It is. That's why I start off with the first single digit divisor. Single digit
Mhm.
divisor is where I start off with. And then we do single digit by 3 digit dividend. Then you can get used to the pattern. And then after you get used to the pattern, then you can add more numbers. But it gets more
Mhm.
complicated because you start mixing in minus the 5 and minus the 10. And then it gets even more complicated when the quotient is too big. So there's a little
Okay,
bit more to division than just what we have.
I see.
Yeah.
Okay, makes sense to start small. To start small. Okay,
Hmm. Hmm.
yeah.
And so, and that's the one thing is trying to figure out how to outline the book to make it more smaller steps.
Hmm.
So,
I
I mean,
agree with you on that one.
yeah, like you've seen my books. They're pretty small. Even with the adding and subtracting, they're very small. And so I want to follow that same path when I do multiplication and when I do division. That's why it's taking me a little bit longer to process and outline those books.
Mm. Well, you've done a
And
great job. So, and
yes,
just explaining everything. Because you, like I said, you explain the whys, and I
Yeah,
think it's so important to know the whys. It
thank you.
really is.
especially for those of us that need to know the why. Why am I
Yeah,
doing this? I drove my math teachers insane.
yeah, yeah,
Why are we doing this? And they can never give me a answer that I was happy with.
yeah, yeah.
Hmm.
It is a different skill to get to that why. It is harder.
Hmm.
I'm not, it is harder to, because if you have 30 students asking you why, you know, so trying to
Yeah.
get everybody up to speed is tough.
It is. Well, I remember in college, we were learning the whys of math then
Yeah.
because we're going to be teachers and we're going to be teaching them.
Hmm.
So, and and especially if we're going to be having our children, if we're going to, we want to be able to have them be able to teach them, not just teach them how, but we want them to understand the why. And I know that that why comes after a while when you start to have more practice, because I remember when you're teaching the abacus, you would say, well, we just want them to just know the formula.
Yeah.
And then once they get to practicing it and noticing the pattern,
Mhm.
I think maybe does the why speak for itself, or do we guide them
Yes.
into that why?
We guide them into the why and it comes more visible. But
Okay.
but it depends on how young the kids are. If the kids are young, they're not going to know why, they just know to do it. It
And
is
then,
up to them to figure out if what the why is. You could tell them. I
yeah,
mean, you're already telling Abram, you know what I mean? So it's
yeah.
good. But he's at that age where you can tell him and he makes sense to him. Like you can't tell a 5-year-old. You might. You can tell a 3-year-old, you might, but I don't think they would understand. I don't know. I this is the new realm that I'm trying to get into, like showing the why, because even in abacus world we tell the kids to memorize because we try to because they mimic, the western, just memorize, memorize, memorize. I am
Yeah.
coming from a different path. I'm coming from a no, no, no. You know what? Try telling them the why. And even when they're 3, Or 4, you have to tell them why. Maybe that will get them to start understanding critical thinking.
Mhm.
Maybe that's what it is. Maybe we should start them early, right?
Mhm.
Instead of saying like, instead of like, how do you make this number? It's why are we making this number? And then they can start filling in their own narrative. Maybe that's a good idea.
Mhm.
To
Well,
ask them why. Why are you doing it this way? Because they ask us why. Why are you doing that? Well, you tell them, well, why are you doing it? You know what I mean?
mhm. When we were doing in your book, when we were doing the cats in the tree, you have the
Mhm.
plus fours, and my husband asked him, okay, do you see a pattern? But he didn't see the pattern yet
Mhm.
until just recently.
Yeah, it takes time.
Yeah, it takes time. He's just doing them. And then he's like, oh, there's a
Mhm.
pattern here.
Yep.
So, and if they can start to recognize the pattern, maybe that's when they're actually ready for the why.
Probably. Yeah. Yeah.
Um, so this has been great. This is awesome.
Yeah. That's what I'm saying. Like, I don't want to stop office hours because we get into really deep conversations.
Mhm. Well, you just
Yeah.
helped me how to see how everything, with the division where the quotient actually moves. That was
Yeah.
awesome. Because I didn't get that. I didn't get that at the very. I'm trying to keep up of how to subtract and keep my finger in the right place, and so
Yeah.
I'm not seeing that something's actually moving across.
Yeah.
Because that's just so much for your eyes to actually see and do. Thank goodness you take your finger and you point and you don't move it until we moved on to the next part. Otherwise, I'd probably be lost.
Yeah. Yeah, I think so. I mean, that's the beauty of being able to teach, live as opposed to teaching is watching somebody else's video. And I don't know. I don't know. It's just one of those things.
You've
Well,
watched other you've
I've
you've
gone
watched
back
other
trying to.
videos.
I'm sorry.
You've watched other abacus videos and how they did the division.
Yeah,
And yours is a little bit different, correct?
I think it is. But I'm also very American.
Okay. Okay. I love it. I love it. Okay.
Well,
Okay,
I've
honey.
gone back to some of the other videos that I was trying to watch, and I still can't understand what they're doing
Yeah.
without without the formulas and stuff. Like, yeah,
Yeah.
no.
Yeah. It yeah. But I think that's what it is that because I have an American upbringing, I can bring in the American thought process.
Hmm.
Okay.
That's what that means. Because because I'm Chinese. I'm trying to learn Chinese. I try to learn Chinese from native Chinese speakers, but it doesn't gel with me. There's this American that went to China for 8 years. He is talking Chinese. He makes a lot of sense to me. And I was wondering, and it's because he has that American thinking to be able to relate to how does it work in Chinese. And I see the
Mhm.
difference.
Uh-huh.
Okay.
Okay.
It's not because of the accent or anything. I think it's just and I think the difference in the American abacus teachers that are here don't take that extra step to try to relate it to American math because to them it's still an enrichment program as opposed to I'm thinking that we need to share this to the average people. Does that make sense? Like I'm average, right? I'm not super smart or anything, but if I had this abacus, I think I would be a lot further on than where I am right now. Well, I mean, I love what I do. I'm not, don't get me wrong, but what I'm saying is it would give us that extra edge if we just had that abacus
Mhm.
instead of all the
Yeah.
different strategies that they teach now. Because I feel like that they're overcomplicating um, basic adding and subtracting because I feel like they need to make it philosophical. But there's only so much abstract thinking that children can do at that age because they don't have the frontal lobe developed yet. Even doing physics. You can't tell a child to do physics yet. They could see it go up and down, but to do that actual calculations is not, they need to get that frontal lobe going. And we as humans don't develop that until later on. That's why we're so vulnerable at such a young age. We can't walk, right, when we're born, but you talk about a cow, they can walk instantly.
Yes.
And that's the difference. So it takes time, and let it marinate, let it sit, let it, let it just kind of sink in, because your brain does do more thinking than you know it does.
Yes.
I like it. Yep, it does.
That's why when you go to bed at night, you've got a problem you're working on. You don't have an answer till you get up the next morning.
Yeah. Or you get that solution when you're in between that twilight stage. I remember when I was doing physics and I was like, there's this problem. And they made it super complicated. But as I just about fall asleep, I was able to make it so simple that it was really easy for me to just, get through it.
Right.
So, all right, ladies.
Trying to write this formula down, and I'm writing the wrong number in the wrong spot.
Yeah.
It doesn't work.
Oh, before I forget, one more thing. Tammy, you know what you could do is you could go back to your previous, go back to your previous mazes. And I was looking at it, and you could do this. Color in the opposite ones. If you need to practice. Oops.
What do you mean?
So I have my path. This is my path. What I did is I colored in the ones that are not part of the path.
Oh, okay.
You could do that if you just want to do some extra coloring.
Yeah, I could.
If you want. I just thought of that.
I hadn't thought about it, but yeah.
Yeah, because I was trying to do the live, and I was like, how is this another way? Can I, so yeah. Anyways, I am going to head out.
Okay.
Thank you again. Thank you, ladies, for joining.
Yep, thank you.
Most
I
definitely.
learned something every time I come on. I learned something new.
Well, that's good. That's good.
And I love that we were getting to do division, so I'm happy.
Yeah, yeah.
It's giving me more practice.
Yeah,
and I like the fact that it's giving you practice as far as trying to figure out how to teach it.
Yeah, exactly. Yeah, and that's, and I do appreciate it. And that's why I enjoy this part of office hours, because I can get into more deep dive, because you guys already know the basics. I just need to keep introducing the higher concepts. Yeah, there was one person that were like, you should have like 2 streams. And I'm like, well, you could pay for that. And that's what they're doing. That's what you guys are doing. You guys are paying for it. You know what I mean? So
yeah,
I appreciate it. I appreciate it.
Yeah.
Oh, not a problem.
Yeah, thank you. I really appreciate what you do. So
I'll see you again.
Okay.
Yeah.